Hello friends. So today we are going to start with a new chapter in standard 8th physics, that is chapter number 5, light energy. Now we very well understand up till now in 7th standard that light is a form of energy and which is enabling us to see something, like we are able to see the objects around you because light is falling on that thing, getting reflected and entering into your eye. The reflected light which is entering into your eye forms the image of the object which is placed over there. So it is the reflected light which we see from an object which is enabling us to see an object. And that's the reason if you have got a transparent glass in front of you, like for example those who are wearing specs, can you actually see the lens of your specs? No, unless until there is some dirt particle or something on it. Why is that so? Because the specs, the glass is made in such a way that it's almost transparent, so it is not reflecting the light, and that's why when you are having it in front of you, you cannot see it. Okay, you cannot actually know that there is some kind of a glass present over there. So the light is enabling us to see the objects. Now it is also known that light is something which is traveling as the fastest. Okay, the fastest thing anything can travel is light, and that is the speed of light is given as 3 into 10 raised to 8 meter per second. That is 3 and then 8 zeros. Okay, 3 and 8 zeros. That is 1, 2, 3, 4, 5, 6, 7, 8 meter per second. This is the speed of light in air or vacuum. So if it is air or vacuum, then the speed of the light is 3 into 10 raised to 8 meter per second. But this speed is dependent on the material through which it is passing through. So if any material is such that which is denser than air, automatically the speed of the light is going to decrease. Okay, the speed of the light decreases with the increase in the density of the material medium for propagation. Exactly ulta of sound. साउंड में क्या था, जितना डेंसर मटेरियल उतना स्पीड ज्यादा, यहाँ पे उल्टा, जितना डेंसर मटेरियल उतना स्पीड कम. ओके, इनवर्सली रिलेटेड. मोर द डेंसिटी lesser the speed in case of light. So we see that because we know that vacuum is something which is the least density. Vacuum के कोई density हो ही सकती, because vacuum is nothing. So when the light is passing through vacuum at the speed of 3 to 10 raised to 8 meter per second, that means that is the fastest that light can travel in any medium. Light can travel fastest in air or vacuum. So if I'm using glass or water or maybe any particular transparent medium, my speed of light is going to keep on decreasing. Okay, so the speed of the light is going to decrease. So speed decreases with increase in density of material. Or okay, so if the density is more, the speed will be less. If the density is less, the speed of the light will be more, which is passing through. Of course, we are talking about only transparent medium, because if it is not a transparent medium, the light cannot pass through, it will just get reflected back. Okay, like for example, you are able to see me because I am not a transparent object, so that's why the light is not passing through me, right? It is getting obstructed and getting reflected back, and that's why you're able to see me. So this is how that density is going to play an important role. So here we see that speed of light in different media. In class 7th, we have read that light travels faster in air than in water or glass. The speed of light in air is 3 into 10 raised to 8 meter per second. In water, it is 2.25. So in case of air, is equals to 3 into 10 raised to 8 meter per second. In water, it is going to be equal to 2.25 into 10 raised to 8 meter per second, right? And in glass, it is only glass, it is 2 into 10 raised to 8 meter per second. So we find that glass is much more denser than water, right? In the language of physics, we say that glass is optically denser than water, and water is optically denser than air, or air is optically rarer than both water and glass. So optically denser means whose density is more and the speed automatically of light decreases. Optically rarer means whose density is going to be less, and hence the speed of light will be more in case of rarer medium. So you have got two kinds of medium now. Accordingly to this, what is the two kind of medium? One is a denser medium and other one is the opposite of that, which is the rarer medium. So denser medium and rarer medium are the two kinds of mediums which are available for, which are the transparent medium available for the propagation of light. Okay, so light will travel through a denser medium, means speed is less. Rarer medium means speed is more. Thus a medium is said to be denser if the speed of light is in it decreases, while it is said to be rarer if the speed of light in it increases. But in no medium, it can be more than 3 into 10 raised to 8 meter per second, because no medium can be less denser or it could be rarer than vacuum. Okay, vacuum is no particles at all, and hence it is the least rare, the most rarer kind of material is nothing but vacuum. So that's why the speed of light can never be more than 3 into 10 raised to 8 meter per second. Now it is seen that when you take a glass of water, okay, you take a glass of water, and in the glass of water you place a spoon. Okay, so when I place a spoon inside the glass of water, I'll just show that. Okay, so it is seen that if I take a glass of water and into this glass of water I have placed a spoon like this over here. So this is a spoon which is like this. Now it is seen that when I fill this up with water, it will be seen that this particular spoon will no longer look like this. Okay, the spoon will not look like this, but it will look as if it is broken. So the spoon will be seen something like this. के यहाँ पे तो सब कुछ बराबर रहेगा, but ये वाला ऐसा bend होके ऐसे आएगा. So that you can easily see even in your house. ग्लास में ग्लास के अंदर पानी भर दो, पहले या तो स्टिक डाल दो, देख लो, स्टिक डालो, पेंसिल डालो, स्पून डालो, जो डालना डाल सकते हो. Okay, just take one particular thing which is long enough, and then you see it, and then you pour water into it. You'll find that it will look as if that particular pencil or that particular stick has broken into two pieces. And it feels as if it is broken. So what is this? This particular phenomena by which the path of the light is getting changed. Okay, this is nothing but refraction. See, in the earlier class, that is in the 7th standard, you had learned something about reflection. So reflection was that the light ray are going to follow a path which is going to be, after reflection it follows an angle exactly same as the angle which was followed with the so if this is the mirror, if the light ray is falling over here like this at an angle of, say, let's say 30 degrees over here, then this angle after reflection also it will be going in such a way that यहाँ पे भी 30 degree होगा. Now this is incident ray and this is reflected ray. It is reflected ray and this is called as a normal. Now this we had studied in the 7th standard, that when the mirror is like this, so mirror के सामने अगर कोई light रहेगा, so it is going to form an image. It will be such that the angle of incidence is equal to angle of reflection. So that is reflection. But now what we are studying is this, that is the bending movement of the object when placed inside a denser medium. Now this particular thing is called as refraction. Okay, that is refraction of light. So light travels in a straight line path in a medium, but when a ray of light traveling in one transparent medium falls obliquely on the surface of another transparent medium. So what exactly happens is, suppose I have got this particular layer of what? This is air over here. So this part is air and this is water. And there is a ray of light which is going to fall like this. Now when this falls like this particular ray of light is called as the incident ray. And this incident ray makes an angle with a perpendicular drawn over here, and this angle over here is called as the angle of incidence. Okay. Now normally what should have happened is that when it's traveling from here to here, it should go straight. यानी ये ऐसा straight जाना चाहिए, but that doesn't happen. It is seen that instead of going straight, this particular line bends. So it is going to be, so this is the normal. So okay, it is seen that this particular ray of light, instead of going like this, it bends towards the normal. यानी ये जो ऐसे जाने वाला था, it was like this, that the ray of light was going like this. Instead of that, after it reaches inside the water, it is going to bend a bit like this and go like this. Okay, so instead of going like this, it is going to go like this and then bend and go like this. So this is the bending movement which is going to take place, wherein when the ray of light travels from, this is called as a rarer medium to a denser medium. So when it goes from rarer to denser, it is going to go towards normal. Okay, so when the ray of light is going to travel from rarer to denser, the ray of light is going to be towards the normal. There is a bending movement such that the ray of light will be bending towards the normal. Okay, so we see over here, light travels in a straight line path in a medium, but when a ray of light traveling in one transparent medium falls obliquely on surface of another transparent medium, that is, it is like this. Obliquely means at an angle, not straight. Perpendicular रहेगा तो सीधा सीधा चला जाएगा. पर ऐसा angle में जब ये हो गिरता है, तो it is falling obliquely. Okay, it is falling obliquely on the another transparent medium. It travels in another medium in a direction different from its initial part. So here it is traveling at a angle, which, or we can say it is traveling at a pathway. The path is different. The path is not the same. It is not the same old path. The blue color नहीं हो रहा, अभी वो red पे जा रहा है. क्यों? So that is nothing but reflection. So the change in the direction. So this is the definition of refraction. The change in the direction of the path of the light. The change in the direction of the path of the light when it passes from one transparent medium to another transparent medium, or you can say when it passes from one optically transparent medium to another, is called as refraction of light. It is called as refraction of light. So what is that? That when the change in the direction of the path of a light, when it passes from one optically transparent medium to another medium, it is called as refraction of light. So it is seen that experimentally when we see, it will happen this way, that if the ray of light is going to pass through from like if I got over here, from a rarer medium to denser medium, it is going to go towards the normal. So from rarer, that is rarer, to denser, so that is R D towards the normal. Okay, I will not write anything here. Okay, so that is R rarer to denser towards the normal. Now the same way, if this particular ray of light is such that this is air and this is glass, or else let me make it ulta in this way कि यहाँ पे हम लोग proper लिख देते हैं कि this is glass, that is denser, and this is air, which is rarer. And if the ray of light is going to pass from like this, so it should have gone like this. This is the normal over here. Okay. So this is the angle of incidence over here. So it is seen that instead of going in a straight line like this is going to take a path which will be away from the normal. So this is denser to rarer, away from normal. Okay, this is the normal. This is the normal. This is the incident ray and this is the refracted ray. Okay, this one is called as the refracted ray. This angle what is going to be there over here will be called as angle of refraction. And the change in the path over here, this angle over here is called as angle of deviation. Because it has deviated from its original path, so jitna deviate hua, that is called as the angle of deviation. So now we can see that it is experimentally observed that when a ray of light travels from a rarer medium to denser medium, say from air to water or from air to glass, it bends towards the normal as shown in the figure over here. Okay, rarer to denser towards the normal. And when a ray of light travels from a denser medium to rarer medium, say from water to air, it bends away from the normal as shown in the figure 5.2, that is this one. Okay, so denser to rarer, away from. So I remember it this way, that this is denser, rarer, away. So that is DRA. You can call it as Dr. A or Dracula भी जैसा कुछ भी बना सकते हो. It's your choice. Basically याद रखने के लिए कि okay, denser, rarer, away. तो automatically दूसरा क्या रहेगा? Rarer to denser towards the normal. So this way you know that whenever the ray of light is passing from denser to rarer, what will happen to it? Denser to rarer, automatically it will be away from the normal, and from rarer to denser it will be towards the normal. Third thing is, but yes, very important, if this ray of light would have fallen like this, that is perpendicular, that is 90 degrees, it would have gone undeviated. There would not be any deviation when it is going to travel perpendicular to the surface. So when a ray of light falls normally means perpendicularly, okay? Normally on the surface separating the two media, it passes undeviated, that is along the same path as shown in figure 5.3. So you can see in figure 5.3, the ray of light is just passing through straight without any bending. Why it is not bending? Because it is perpendicular to the surface. When it is perpendicular to the surface, it will not bend at all. Note, when a ray of light passes from one transparent medium to another transparent medium having the same refractive index, it also remains undeviated. Now here it's very important to know that we can say there are two conditions which will take place, which will not allow the refraction to take place. The first condition is that I can write it down over here. The condition will be, first condition will be that the ray of light is perpendicular to surface. If the ray of light which is falling on the particular transparent medium is perpendicular to surface, then there won't be any deviation. The another thing is that if density, optical density, okay, it is optical density of both medium is same. For example, I have a glass over here and water over here. And suppose the glass is made in such a way that both water and air have got the same optical density. If the optical density of both the medium is the same, then there will not be any kind of bending taking place. So in such a condition, irrespective of कोई भी angle से उसको मैं डालूं, light को उसके ऊपर डालूं, the light will just pass through without any deviation, because both the separating medium, जो light ये water है और ये glass है, अगर दोनों के दोनों का optical density is the same, if both are same, has the same density, then they will be not having any kind of bending moment. So that's why I written over here, when a ray of light passes from one transparent medium to another transparent medium having the same refractive index. So this density, optical density, is measured as refractive index. Okay, कितना refraction करेगा? Okay, कोई भी object, कोई भी transparent medium कितना refraction करेगा? That is nothing but the refractive index of that substance. So if water का refractive index and glass का refractive index same है, then there would not be any refraction taking place and it is going to pass through straight line. So it is going to remain undeviated. Now certain terms which are very very important for refraction of light. So this you need to learn by heart. So very important. Incident ray. So what is the incident ray? This is the incident ray. So the ray of light falling on the surface separating the two media is called as refracting ray. So the ray of light which is falling on the reflecting surface, okay, so separating the two media is called as the incident ray. Refracted ray, the ray after refraction, तो bending होने के बाद में ये जो हुआ, that is this red color one, this red color one, or this one over here. These are the refracted rays. That means the path which it is followed after it has got refracted by the change in the medium. So the light ray traveling in the other medium in the change direction is called as a refracted ray. So other medium में जो light pass हो रहा है in the change direction is called as refracted ray. Third is normal. What is normal? The perpendicular drawn over here. The perpendicular to the surface, what is drawn over here is the normal. Okay, that is the normal. So over here, this blue color dotted line, what you can see over here is the normal. This is the normal. Okay, normal is nothing but the perpendicular drawn. So the perpendicular drawn to the surface separating the two media at the point where the incident ray strikes it, that is the point of incidence, is called as the normal. So the perpendicular drawn at the point where it is the incident ray is falling. Okay, this is the point where the incident ray is falling. This particular point, वहाँ पे जो perpendicular हम लोग जो draw करते हैं, that is called as the normal. Angle of incidence, of course, that is the angle between the normal and the incident ray. Now remember this thing. The angle of incidence is between the normal and the incident ray. It is not between the surface and the incident ray. It is not this angle. It is not this angle. ये नहीं है. ये वाला angle नहीं है. ये वाला angle है. This is the angle which you are talking about between the normal and the incident ray. So the angle between the incident ray and the normal is called as the angle of incidence. And angle of refraction will be the angle between the reflected ray and the normal is called as angle of refraction. So these are the very important 5 definitions which you need to learn by heart, because they will ask you as definition of incident ray or normal or refracted ray, angle of incidence, angle of refraction. So that is a direct questions over here. So this is what they have explained over here in figure 5.4. So 5.4 shows the light ray OA passing through from the rarer medium air into a denser medium glass. XY is the surface separating the two medium. AO is the incident ray. OB is the refracted ray. NOM is the normal of, at the point of incidence of O. That is the point of incidence O. The O is this particular point. Okay. Angle AON is the angle of incidence, that is angle I, and angle BOM is the angle of refraction, that is angle R. It is clear from the diagram that when the ray of light travels from air to glass, it bends towards the normal. That is, instead of moving in the earlier direction shown by the dotted line OC, the ray bends towards the normal and moves along OB. That's why angle of refraction is less than angle of incidence. You can see the angle of incidence is this big, angle of refraction is so small. Okay, this is the angle of incidence, this is the angle of refraction. So this is smaller, right? In figure 5.5 shows the light ray OA passing through a denser medium glass to a rarer medium air. XY is the separating medium, surface separating the two media. It is clear from the diagram that angle incident ray OA bends away from the normal and is reflected as OB. Angle R is greater than angle I. So here you can see that this is angle I and this angle is angle R. So you can see over here that angle R is greater than angle I in this case. Well, over here this is angle I and this angle R. So this angle R is less than angle I. Okay, so this is the explanation towards this part. Now we see the laws of refraction. I better continue in the next video.